Neon has 3 stable isotopes, neon 20, neon 21, and neon 22. If the abundance of neon 20 is 90.48%, what is the abundance of the other 2 isotopes? So for any isotope abundance problem, there's kind of a general approach you always want to take. And that is looking up the mass of the element you're working with from the periodic table, because that mass is calculated by averaging all the isotopes. So you always can just look that up. That's the first thing you should do. And then that will be set equal to each individual isotope's mass times its percent abundance. And you just add them together. And each element has its own specific number of stable isotopes, but the problem will always tell you that, or how many it has. So for this specific problem, the first thing you want to do is just kind of write down what you're already given and what you need to solve for. So for the first isotope of neon 20, it's given to us that its percent abundance is 90.48%. For neon 21, we don't know that, so we're just going to call that X. And for neon 22, that one's also unknown, so we're going to call that Y. And then we're going to just kind of work with this and kind of plug in what we know into this general formula up here. So if you look up neon on the periodic table, its mass is 20.180 AMU. And then we're just going to set that equal to our first isotope, which its exact mass is given in the problem, and that's 19.992 AMU times its percent abundance, which is 0.9048. Make sure you put it in decimal form. And then adding to our second isotope, the mass given for that is 20.994 AMU, and we called that percent abundance as X. And then for our third one, that third mass is 21.991 AMU. And so we assign that percent abundance Y, but you're going to want to put it in terms of X so you can solve for X. So we know that all 3 of these percents have to add up to 1. So you can just set 1 equal to 0.9048 plus X plus Y. If you subtract this over to the other side, you get 0.0952 equals X plus Y. And then solving for Y in terms of X, you get Y equals 0.0952 minus X. And now we have a little formula for Y in terms of X that we can plug in over here. So I'm just going to multiply that by the mass of the third isotope. And then the next thing you want to do is just kind of simplify this line, and you can combine things with an X and just numerical values. So for this first one, you get 18.089. Here it's the same thing times X. And here you just want to distribute the 21.9 to both terms. Oops. And make sure you don't miss the negative in front of the X. And here, again, the next line, just simplify it a little bit more. You can do this all in one step, but I think it's easier to make mistakes that way. And so you get 20.183 minus 0.997x. So then just subtract the 20.183 over, and you get negative 0.003 equal to negative 0.997x. Then just dividing both sides by the negative 0.997, you get x equal to 0.003. So this is our term for X, and that means the percent abundance of neon 21 must be 0.3%. And then our percent abundance of Y, we can just plug the 0.003 into this equation that we already solved for. So 0.0952 minus 0.003 gets us 9.2%. And then just as a little check at the end of our problem, we can just add up the 3% for each isotope and they should equal 100%.